Welcome to my next installment in the video lecture series that I'm putting together for economics. And in this particular video lecture, I'm going to be taking a look at a topic for intermediate micro, and this has to do with the Solve Problem 2.1 from this particular course. And that question is stated, given that the demand function for avocados is equal to Q equals 160 minus 40p, and given that Q is in millions of pounds, how much would the price have to fall for consumers to be willing to buy 1 million more pounds of avocados? And the first thing that you need to do is express the price that consumers are willing to pay as a function of quantity, which is the inverse demand function. So we here have our demand function that we were given for this problem. We need to convert this into the inverse demand function. So if we add 40p to both sides, the negative 40p and 40p here will cancel out, and this will yield Q plus 40p is equal to 160. We can then subtract Q from both sides because we want the P to be alone by itself on the left-hand side. So subtracting Q from both sides will give us 40p is equal to 160 minus Q. And if we divide through by 40, we end up with P is equal to 40 minus 0.025 Q. So that is the inverse demand function. So make sure you're aware of that if you're given the demand function, you may need to convert it to an inverse demand function, in particular for this problem, because we're concerned with if Q changes, how is that going to impact the price? So we need to get what P is equal to as a function of quantity. Now we need to know how P changes with respect to changes in Q, and we can rewrite it as that form here, where the change in P is equal to negative 0.025 change in Q. I want you to realize that the 40 here just drops out when we're doing this. The reason being that this is a constant. This never changes. So the change in 40 is equal to 0. So if we're taking the change of this, this becomes 0. So then we just have change in P is equal to negative 0.025 change in Q. As the problem stated, we wanted to see how much the price would need to change in order to cause quantity demanded to increase by 1 million pounds of avocados. Since Q is denominated in millions of avocados, we just need to place the 1 in here in place of change in Q because this is in millions of avocados. And if we multiply that through, the change in the price is equal to negative 0.025. So in order to induce people to consume 1 million more pounds of avocados, the price has to fall by 2.5 cents.